If you've ever driven through Texas or Oklahoma, you've definitely seen them. Huge iron monsters standing alone in the middle of a field, slowly bowing toward the dirt and back up again. Over and over. In the US, we call these pumpjacks. They look sluggish, maybe even outdated, like a mechanical toy from the Industrial Revolution. But don't let that slow pace fool you. While people are sleeping, eating, or watching this video, these machines are out there grinding 24/7. No breaks, no holidays. They have one job, pulling money straight out of the deep earth. But it raises a question. Why the nodding? I mean, it's the 21st century. Why not just use a modern, compact electric pump and call it a day? Why build this massive, clunky frame just to bob up and down? What's happening miles underground that we can't see? Let's break it down on Simple but Surprising. Everything starts with a party. When a fresh oil well is first drilled, the natural pressure is so intense it forces everything to the surface. It's exactly like shaking a bottle of soda and popping the cap. Boom, the oil sprays out and the money starts flowing. But back in 1920s, Texas, that high didn't last long. As wells got deeper, the pressure crashed. The oil became lazy, sitting miles underground with no intention of coming up. If you just left it there, you were looking at millions of dollars in lost profit. The problem was the tech. It was honestly a joke. Companies were using these massive, ancient systems that were basically trying to drink a thick milkshake through a cracked straw. Tons of effort, but you barely got a drop out of it. Then, in 1925, an engineer named Walter C. Trout stepped in and basically said, "I've got this." He sketched out a design that changed everything, the counterbalanced pumpjack. However, when Trout first set this thing up, it wasn't exactly greeted as a masterpiece. In fact, Trout later joked that while the machine ran perfectly, people actually laughed at him. They mocked the curved horse head and the rhythmic nodding, calling it a stupid donkey. It took Trout nearly an entire year of grinding just to convince the oil tycoons that this goofy-looking thing actually worked. His company Lufkin went into mass production, and a century later, we are still using his exact design. So why was it such a breakthrough? Why is that nod more efficient than any of the massive machines that came before it? A motor running on gas or electricity spins a heavy crankshaft, but since you can't exactly screw oil out of the ground, that circular spin is useless on its own. You need vertical power. The walking beam handles the translation, converting that rotation into a powerful, rhythmic nod. That iconic curved block at the front, we call it the horse head, and its job is pure precision. That curve ensures the steel cable stays 100% vertical as it plunges into the earth. If that cable is off by even an inch, the friction would shred the wellhead to pieces in no time. Connected to that cable is a string of steel rods reaching deep into the ground, sometimes as deep as 10 Empire State Buildings stacked on top of each other. The horse is simply brute forcing that massive weight up and down, over and over, millions of times. But here's the reality check. Each nod only brings up about 1 soda can's worth of crude oil. It sounds almost laughable when you look at the size of the rig. Coming back to that thick milkshake from earlier, this is exactly where the suction happens. The secret lies in 2 little components, the standing valve and the traveling valve. They take turns opening and closing with perfect mechanical rhythm. And this is the part where the machine actually cheats physics. When the horse lifts its head, it pulls the piston up, creating a powerful vacuum. At that moment, the bottom valve opens, inviting the oil into the cylinder, while the top valve stays shut to hold the massive column of oil above it from crashing back down. As soon as the horse nods, the piston drops. The bottom valve slams shut so the oil doesn't get pushed back into the dirt. Simultaneously, the top valve pops open, letting the piston slide through the oil it just trapped to get ready for the next pull. With every single nod, the oil gets pushed up a little higher and then a little higher until it finally hits the surface. If you watch a Pumpjack in action, you can't miss that massive iron block swinging on the side. It looks like a rusty weight from a 1950s gym, just bolted on there for no reason. But believe it or not, that hunk of metal is the economic brain of the entire operation. Think about it. The motor isn't just lifting a soda can of oil. It's trying to heave a string of steel rods that weighs several tons. If you tried to do that with pure motor power, the machine would burn out in minutes, and your electricity bill would look like a phone number. That's where the counterweight becomes a gravitational cheat code. Instead of fighting gravity, the machine uses it. When the arm dips down, gravity pulls that heavy counterweight down with it, storing up energy like a massive battery. Then, when it's time to haul those tons of steel back up, the weight swings upward, using its own momentum to heave the load. Without this dumb piece of iron, the motor would overload and go up in smoke in a heartbeat. It's the ultimate example of working smarter, not harder. So, that's how a 100-year-old design is still quietly keeping the world running. But it makes you wonder, in an era of AI and SpaceX, is this iron horse really the best we can do? Or are we just too lazy to fix something that isn't technically broken? Well, don't let the rust fool you. These old machines are actually smarter than most of the gadgets in your house right now. Today, those chunky steel frames have been injected with a serious dose of Silicon Valley. We're talking a full swarm of IoT sensors and smart controllers. If the oil flow slows down or the pressure underground shifts, the machine doesn't just keep blindly hammering away until it explodes. It's smart enough to throttle down or even put itself to sleep. In the industry, they call this a pump-off controller. It's basically a smart nap. The machine waits for the underground oil pocket to refill before it gets back to work. Meanwhile, those sensors are tracking every tiny vibration and every degree of engine heat. Operators can sit in an office hundreds of miles away, look at a screen, and predict a breakdown weeks before it even happens. It stops that nightmare scenario where every hour of downtime literally evaporates thousands of dollars. But the most impressive thing isn't the smart part, it's the longevity. In a world where your iPhone starts acting up the second the new model comes out, these pumps are built to last forever. It's not rare to find a machine that's been on the job since the 1960s, back when humans were first stepping onto the moon, and it's still out there today, nodding away like it hasn't missed a beat. The truth is, in the oil business, flashy is a fast way to go broke. If you tried to use a high-tech, high-maintenance system on these wells, you'd be bankrupt by lunch. The electricity alone would cost more than the oil is worth. That's why the Pumpjack is the ultimate survivor. It's the broom of the industry, cheap, bulletproof, and designed to wring out the very last drops from aging fields. These sleepy giants contribute about 7% of total US production. Without them, hundreds of thousands of wells would be abandoned, leaving billions of dollars trapped underground forever. They might not have that futuristic Tesla aesthetic, but they get the job done. That's why, no matter how high-tech the world gets, you'll still see these iron horses on the horizon, from the Texas plains to the Middle East, quietly nodding away. Next time you see those silhouettes on the horizon, remember, that's not just scrap metal. It's a machine that has outlived trends, outlasted generations of technology, and still keeps doing its job. That slow nod is not a sign that it's primitive. If anything, it's proof that sometimes the simplest looking solution turns out to be the one with the most staying power. So I'm curious, which impresses you more? Brand new technology or old school engineering that refuses to quit? Let me know in the comments. And if you enjoyed this breakdown, subscribe for more.